Okay, here's example 2. Rachel is planning to start saving for her pension by making regular deposits of $2,500 every 6 months after her 35th birthday. The plan she has chosen earns 9% per annum, compounded semi-annually. How much will Rachel have on her 60th birthday? Now, let's think about whether or not this is an annuity or just compound interest. So, what it tells me here is that she is making regular deposits of $2,500. Now, is this a one-time investment or is this regular payments being made? If it was a one-time investment, it would be compound interest. But this is not a one-time investment. It clearly says that she is making regular deposits of $2,500 every 6 months. So she is regularly paying $2,500. Every 6 months she's doing this, so that by her 60th birthday, she has a lump sum of money. So what kind of problem is this? Well, it's a future value of an annuity problem because she is making regular payments into an account so that she has a large amount at the end of the investment time. Okay? So, one thing to notice is that this is definitely a future value of an annuity. So I'll start with the future value of an annuity formula. So A equals R times 1 plus I to the exponent n minus 1 all over I. And I'll substitute in the information that I know. I know the regular deposits that she's making is $2,500. Okay, the interest rate. Now, remember that in order for this to be an ordinary annuity, the compounding period and the payment period has to be exactly the same. So she's paying every 6 months, so that's twice a year. And interest is compounded semi-annually, and that is also twice a year. So far, so good. So, her interest rate is 9% per annum, compounded semi-annually, so I need to divide that by 2. So there's her interest rate per compounding period. The number of compounding periods, well, I know she's getting interest twice a year, since she's getting it semi-annually, or she's making 2 payments a year, so that's twice a year. But how long is she investing for? How many years? Well, from her 35th birthday to her 60th birthday, that's 25 years. So she is making 2 payments every year for 25 years. So that gives you a total of 50 payments that she's going to be making. Okay? Twice in her 36th year, twice in her 37th year, etc., all the way until she is 60 years old. Okay? Now that we have all the information we need, let's substitute it into the equation to solve for the accumulated amount. So, the regular payments were $2,500. 1 plus I is 1.045. N is 50, so she's making 50 payments of $2,500. 0.045 in the denominator. And again, because we have all the values on the right-hand side, we can evaluate the entire thing on the calculator. So 2,500 times bracket 1.045 to the exponent 50 minus 1 bracket, so that's just the value of the brackets, equals is the value of the brackets times 2,500, and I'm going to take that and divide it by 0.045, and that gives me quite a large number, so $446,257.57. So if she invests her money from her 35th birthday till her 60th birthday, she ends up having quite a bit of money, $446,257.57. And this is just an approximate answer. So therefore, Rachel would have about $446,257.57. Okay. Now this is just a side question. Well, if the question asks you to figure out how much interest she's earned over that period of time, how would you determine the interest that she's earned? Well, I know for sure that this is not the amount of money she actually put into the account. So any extra money that she earned would be the interest. So let's think about how much money she actually put into the account. So let's think about her actual payments. Okay? So let's think about her payments. Well, she's made 50 payments in total. And each of those payments were $2,500. So she's made 50 payments of $2,500. So let's see how much money Rachel actually put into the account. She put $2,500 into an account 50 times. So she's actually only put into the account $125,000. This is how much money she's actually put into the account. How much interest has she earned? Well, if at the end of the 60th birthday she has this much money, the difference between the amount of money she put into the account and the amount of money she now has is actually the interest that she's earned. So if I do 446, 257.57 minus the amount of money she actually put into the account, we'll figure out how much interest she earned. So if I subtract these values, I get $321,000, $257.57. So this is actually the interest that she's earned over the span of those 25 years. It's quite a bit of interest, and the reason for that is because every payment that she made has earned interest over the 25 years, and it's quite a bit of money that accumulates over time.